Hello students, in this video we're going to discuss about compound microscope. Here we're going to obtain the expression for magnification of compound microscope, and also we're going to discuss the questions which are asked in AHSEC final examination of class 12 under Assam Higher Secondary Education Council. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So this is the ray diagram of a ray diagram of formation of image by a compound microscope that is given in the NCERT. So here AB is the object. Let me write what I have considered here. The ray diagram for the formation of image by a compound microscope is as shown in the figure. Okay, is shown in the figure. Right here, AB is the object. Okay, OB is the object of size H. Okay, and B is the image of AB formed by the objective lens. So compound microscope consists of two lenses. One is objective, another is called eyepiece. Okay, so this this image B is the image formed by this objective lens, this lens. Okay, formed by the objective lens. Okay, and this image is formed between the focus point of this eyepiece and the optical center of this eyepiece, right? So here I have written E. Actually in the diagram it was given E, so let me write. It is by the objective lens between. It is formed between FE and E. Okay, so here you see F0 is the focal point, is the focus point, or you can say is the focus of the objective lens, and FE is the focus of the eyepiece, Okay, and small f0 is the focal length of the objective lens, and FE is the focal length of the eyepiece. Okay, so hope you have understood this. Now here this image, here you can see A double this, B double this. This image A double this, B double this. This image you can see here clearly. So this image is formed by this eyepiece. Okay, this is the final image. So let me mention here that one more thing. A double this, B double this is the final image formed by the eyepiece, right? So now let me go to a new slide and let me take the diagram again, okay, so that I can explain. Before that, pause the video and note all these things, okay, what I have written. So let me mention before a few things here. That is AB, its height is h, and A dash B dash, its height is h dash, and the FB dash here, this length F not B dash, F not B dash, this length here, you see this length F not B dash, from F not to B dash, this is L, okay, and this point F naught is the focus point of this objective lens, and FE is the focus point of this eyepiece, okay. So now linear magnification due to the objective lens, linear magnification of or linear magnification due to the objective is, let it be m naught. That's gonna be, this is the size of the image h dash, and this is the size of the object, this is h, right? So size of the image divided by size of the object, right? So what we can write? We can write h dash by h. This is suppose equation number 1. Now you see from this triangle, here you can see clearly, sorry, this triangle, let us consider this triangle. From triangle A dash, B dash and F naught, A dash, B dash and F naught. So what we get here, tan beta is equal to h dash by, this length is L, I have already mentioned here, this length is L, right? This length is L. So that's gonna be h dash by L, okay, h dash by L. Now you see, now let us take this triangle. Here you can see this very small triangle POF naught, this triangle POF naught, this triangle, okay. From this triangle, tan beta is from triangle POF naught. From here we're gonna get tan beta is equal to here, this part is nothing but equal to the height of the object, right? PO, this PO is equal to height of the object. So here we can write, here you see this h is also equal to PO, right? And this length you see, this is focal length, this part here you see, from here to this, okay, this part is focal length F naught, okay. So here we can write h by F naught, and combining these two equations we can write that therefore tan beta is equal to h dash by L, also h by F naught. So if that is the case, now you see from this relation what we can write? We can write that h dash by h is equal to L by F naught, right? We can write this, okay, h dash by h is equal to L by F naught. If you bring this h here and transfer this L to that side, then you can get this equation. Now using equation number 1 and 2, now you see this is also h dash by h, this is also h dash by h. So from 1 and 2, from equation number 1 and equation number 2, what we can write that m naught, which is equal to h dash by h, which is equal to L by f naught. So let it be equation number 3. This is suppose equation number 3. So now let me write this equation here. Sorry. Okay, and just give me a second, and I'm gonna use this equation number 3 here. You see, let me keep this equation. I'm gonna clean this piece for further simplification, so that's why let me write this equation here. Let me keep this equation here. Okay, pause the video and note all these things because I'm gonna clean this page, okay, for further simplification. So first let me clean this page. Okay, just give me a second. Now you see, consider this situation. Now this A dash B dash is the object for this lens, okay, this eyepiece. Okay, so you can consider the case of simple microscope, that is already I have explained. I have given the link in the description box. I have written simple microscope, and then I have given the link of that video. Okay, so what's that? So what was the expression for angular magnification? That was m is equal to 1 plus d by f. Okay, if we use this formula for this lens eyepiece, because now we can consider that A dash B dash is the object for this lens, and we can compare this part with the simple microscope. In that case, we can write that magnification for this eyepiece, let it be ME, then we can write 1 plus D, and the focal length for this eyepiece is FE, as I have already mentioned earlier, right? So that's why we have got this expression. So now let me clean these things. So now you see, so what I'm going to write here now. You see, the angular magnification due to the angular magnification due to the eyepiece, okay, due to the eyepiece can be calculated considering A dash B dash is the object for the eyepiece, as so write within bracket as simple microscope, considering as simple microscope, okay, for the eyepiece, and the image formed by it A double this, B double this, okay. So therefore okay, the angular magnification due to the eyepiece can be calculated considering this as below. This is, so let it be equation number 4. Okay, so now you see, this object is magnified by this lens, okay, image of this object is formed, magnified image is formed by this object here, A dash B dash, then again it is magnified by this eyepiece. Okay, that means there are multiple magnifications. So therefore we can say, therefore total magnification by the compound microscope is given by, let me write it, m. So that will be product of this m naught and me, m naught and me. Okay, so now let me use equation number 3 and 4 here. Okay, now put the value of m naught, that is L by F naught. Okay, then put the value of me, that is, sorry, it's supposed to be Fe. Okay, 1 plus d by Fe. Okay, so let me write this expression in the next slide. So here you see m is equal to what we have got, L by F naught 1 plus d by Fe. So this is the required expression. Okay, now if the image is formed at infinity, this image a dash b dash, it is at infinity. Okay, if you consider that case, now you see, if the image a double dash b double dash is formed at infinity, now that means you see, if this was the objective lens, this is the object, and image formed by it is a dash b dash, then now if we consider this as an object for this eyepiece, and the image formed by this eyepiece a double dash b double dash, if it is at infinity, now consider this case only, now this case only. So as you know, a simple microscope, then for simple microscope, my magnification is m is equal to 1 plus d by f, and when this image is formed at infinity, then it becomes approximately d by f, and in this case m is gonna be equal to d by fe, right? So in this case, this expression, if the object, this a double dash by b double dash is at infinity, in that case this is gonna be this m e gonna be approximately equal to d by fe, right? So let me write here infinity, then m e is gonna be equal to d by fe. Okay, d by fe, this is suppose equation number 5, and then this equation number 5 becomes of this form, m is equal to L by F naught 1 plus d by Fe. Okay, sorry, this supposed to be d by Fe, right? So when this is formed at infinity, then this expression becomes this form, right? Because this is nothing but me, and the value of me for the image at infinity is given by this expression, right? Hope you have understood this. So now let us see, let us discuss what are the questions asked on, on the basis of simple and compound microscope. So this question was asked in 2023 HS final examination under Assam Higher Secondary Education Council. Okay, so draw a ray diagram to make someone understand how a virtual image may and many times magnified image of an object is formed in compound microscope. That means you have to draw this diagram. Okay, that's it. So now let me take the next question. This question was asked in 2024 HS final examination. Now here the question is, a convex lens of focal length L in an instrument is producing a virtual magnified image at near point D, the object distance u, so that the magnification is given by this expression. So this is for simple microscope, right? Simple microscope. Okay, so I have already made a video on simple microscope, that is in the description box. Okay, go and watch how to obtain this expression, you will understand there. And again, if the image is formed at infinity, then the magnification becomes this. That is also discussed in that same video. Okay, so hope you're gonna understand that. And here position of the object is also asked here, where the object is situated. That object must be between the focus and optical center of the lens. Okay, so that you get magnified and virtual image, right? Okay, convex lens, it should be between optical center, sorry, this is the lens, it should be between optical center and principal focus. Okay, so now let me take the next question. So this question was asked in 2025. Okay, so what is the question here? Now you see, what is the maximum magnification of simple microscope? That is already discussed in the video where I have discussed about simple microscope. Link is in the description box. I have already told you, draw a net diagram. I have already shown in this video earlier, right? Formation of image by compound microscope, this part is done. Write the expression for total magnification of compound microscope in terms of L, D, F naught and Fe. That part is also done in this video, right? So now what will you do for getting larger magnification? Okay, let me write the condition, how you can get large magnification. Let me write here. Okay, so for large magnification, you see, so these are the two conditions for to get the larger magnification. The focal length of the both the lens, objective and eyepiece, should be small. Okay, and the tube length, if it is equal to 25 centimeter, then magnification will be large. Okay, so you can increase the tube length more than 25, but image will be not clear in that case. Okay, so but we need a clear picture, that's why we're gonna keep it up to 25 centimeter, which is the least distance of distinct vision, right? Hope you have understood this. Now what is the next part of the question? Here there is a numerical part. Calculate the total magnification of the instrument. So we're gonna use this formula that we have got now for magnification. Let me solve it here. Let me clean this thing. Just give me a second so that I can solve the numerical part here on the same page. So now you see, for magnification we have got this, that this m is equal to L by f naught 1 plus d by fa. So here you see, we're going to use this expression because it is not given that the image is at infinity. If the image is at infinity, then we should use this expression L by f naught d by fe, right? So just give me a second. So as it is not mentioned that image is at infinity, so we're going to use this expression. So now what we're going to get here, so L is given 20 centimeter, right? So L is given 20 centimeter, f naught is given 1 centimeter, then 1 plus d is given. Where is the d? D is not given. D should be taken as always 25, and fe is given 2 centimeter. So now if you calculate this, then what you're going to have, 20 into 1 plus, so if you divide it, you're gonna get 12 point this, then 20 into 13.5, let's multiply this, so 0.72. so this is the answer. Okay, this is the answer, 270. Okay, so hope you thank you for watching this video. See you in the next video. Bye bye, take care.